In this video, I will demonstrate a different patterning method, a method that is appropriate for projects where you want the seams to be essentially parallel. We will use a real project for the demonstration. This is the Cynthia Woods Amphitheater just outside of Houston, Texas. Today we will repattern this end panel using the auto width method in NDN. I'll start by reading in the model of the end panel. As you can see, most of the panel is fairly flat, but there is a lot of curvature concentrated at the inverted cones. Let's put the model into a nice plan view. I think I'll also save this view. Go into Pattern, and then into Setup to see if the fabric width is defined. It's right here. Okay, now I will add some patterns with the auto width method. All I have to do is locate a starting seam and the direction to pattern in. NDN will iterate to fine-tune where each seam goes so that the patterns fit perfectly on the fabric roll. That last little bit we'll do later. And now the other side. This method is great because it is super fast and easy to use, and it gives you fantastic fabric utilization. If you're wondering, this is the actual speed of the processing. Okay, now I will manually put in the last pattern. And then reorder the patterns. But I won't make you watch me click each one. So they are all reordered. Let's review the patterns. These are the corner nodes where the edge splines will start and stop. This is how the warp direction is defined. And this is the triangulation that defines how the patterns will be unfolded from 3D down to 2D. We know there's a lot of curvature at these low points, so we should refine the patterns here. We can increase the accuracy of the model and the patterns by letting NDN automatically remesh the model such that the element mesh corresponds to the patterns. That is what's happening now. Notice how the seams no longer run over the faces of the membrane elements, but now run along mesh lines. There are now specific membrane elements associated with each pattern. With the model set up like this, we can use the higher tech finite element analysis flattening method. Since we have generated a new mesh, it's best to redo the form finding. It has converged and looks very good. Remember, I would like to make refinements at the rings. We should add additional seams here to help the fabric take on the proper 3D shape. Let's take a look at the actual structure. If you look closely, you will see where we put additional seams in. Let's zoom in and take a look. I'm going to quickly change the patterns here so that we have some additional seams. And then remesh the fabric. Okay, I have edited the patterns at both rings. They should work better now. These are the results from the flattening. We get 2 degrees of shear deformation when we flatten the patterns, which is just fine. The seam style data is defined here. We will now assign it onto the model. We'll put lap seams here, and a chord edge here, and a different detail at the rings. Now let's put 50% decompensation at the rings. And finally, we can write out the data. The compensation goes here. We will ask for cutting patterns, exploded assembly, and a marking plan. So now let's look at the output. This is the marking plan. It's basically a fabric assembly drawing. This is the exploded assembly. The cut lines have all been splined. Notice how smooth they all look. And these are the cutting patterns. they're basically ready to go to your wide area cutter software. I hope you found this useful, and thanks for watching.